Hi, my name is Kurt Ahlich. I'm an engineer with ARCCA Incorporated, and I'm going to give a short talk on retaining walls and retaining wall failures. Site topography often requires roads, driveways, homes, businesses, and landscape features to be built on hillsides or below the ground surface. Often, these improvements or structures are built next to property lines or an adjacent structure, thus prohibiting simply sloping the soil back to a stable, maintainable slope. In these cases, the hillside soil is excavated to a vertical face or bank. These vertical soil faces, which are inherently unstable, must be retained against future earth and soil movement, which would adversely affect anything that is in front of the soil face as well as what would be behind or uphill of the same soil face. The structure that is designed and built to retain this soil face is called, appropriately enough, a retaining wall. It should be noted that retaining walls can also consist of basements, underground parking, or roadway cuts or tunnel walls, to name a few. However, the focus of this discussion will be on walls which may be encountered at typical residential or light commercial developments. I'll also provide a review of general engineering design concepts, a brief description of the different types of retaining walls that may be encountered in the field, ways in which these walls can fail, and how the probable cause of these failures can be determined. Further, we'll have a brief discussion as to how retaining wall failures can be mitigated. From a general engineering standpoint, retaining walls are quite simple. Their function is to prevent movement of the soil that is intended to be retained. That is, the soil located behind the wall. This soil exerts a lateral or horizontal force on the wall. In addition, other forces exert lateral loads on the wall. These forces consist of hydrostatic forces, i.e. water pressure, and surcharge forces related to loads located behind the wall, such as sloping or built-up soil, buildings, or stored items. All these horizontal loads tend to topple, rotate, deflect, or otherwise destabilize the retaining wall. These forces are countered by the weight of the wall, a foundation system, or some type of lateral bracing. A basic question is whether or not retaining walls need to be designed by an engineer and permitted by an appropriate authority. Often, local building code would require that the wall be designed and permitted. A general rule of thumb is that any retaining wall that is over 4 feet in height, as measured from the bottom of the retaining wall, including footing, needs to be permitted. This rule can be restricted by the presence of local code requirements, site geometry, and the presence of structures, including terraced retaining walls, behind the retaining wall. There are multiple types of retaining walls that are commonly constructed. However, these walls fall into a few basic categories, including gravity walls, walls that require some type of foundation, and mechanically stabilized earth. Gravity walls, in respect to residential and light commercial construction, are generally low in height. These walls rely on the weight of the wall itself to counteract the various lateral loads described earlier. These walls typically consist of landscaping retaining structures and are not intended to retain soil greater than a few feet in height. These walls often consist of stacked block or rockeries, which is stacked rock. A more common type of retaining wall is that which requires a foundation. This foundation can consist of a spread-type footing, often constructed of concrete and in a T or L-type configuration, or a caisson, which is a hole drilled into the earth and then backfilled with concrete and a vertical structural member, which typically consists of steel or pressure-treated lumber. Another common retaining structure is what is known as mechanically stabilized earth, or MSE walls. These walls are more common with commercial or multiple family residential complexes and consist of horizontally placed synthetic membranes into a backfilled earth slope. These walls are faced with concrete blocks, which are the same or similar to blocks used in a smaller landscape type wall.